Yeah, okay, thank you. Do you see there my screen?
Yes, yes.
I'm ready. If you want, I can start.
Let's start.
I can start?
Yes, you can.
Okay. Yeah, okay. Thank you, everyone. My name is Housseyni Sankare from Canadian Center for Climate Services. It's part of Environment and Climate Change Canada. In Canada Center of Climate Service, we provide climate data and services. And then before we provide this data, we ensure the reliability of the data. Sometimes we did some bias correction if it need. Today, I will present here the result of our CMIP6 model SST bias correction for the Canadian Ocean region. And the climate change impact ocean ecosystems in diverse ways, altering both the physical environment and biochemical cycles. And then the sea surface temperature is a crucial variable that affects by this change in the climate change. So reliable projection of SST is essential to inform effective mitigation and adaptation strategies. The Canadian Centre for Climate Services evaluated CMIP6 model performance for SST and then applied bias correction to make them available on our climate data portal, naming climatedata.ca. Canada has the world's largest coastline and an extensive marine territory. By the total marine area, approximately 5.75 million square kilometers. This includes the ocean area in the Pacific coast, the Atlantic coast, the Arctic Ocean, including the Houston Bay and the surrounding water. Then the objective for this presentation here, just to show you a comparison of CMIP6 model output bias corrected with OSIA observational data set, and then again make some analysis of SST future projection. For the data and methodology, we used 28 CMIP6 GCMs, historical plus 4 SSPs, and also we use the OSIA data like target to bias corrected the data and also comparing to assess the result. SST bias correction, we done that with the Cantu delta mapping method that we apply to all the 28 models. Each model, first we interpolated them at the 0.05 degree of resolution, that is the OSIA resolution. And then again, we assess the output against the OSIA data. This map here presents the three panels that make the comparison of SST using the OSIA data and the CMIP6 output. On the left side, the left panel shows the annual mean SST from the OSIA data that provide us a higher resolution observational references. And the central panel shows the mean bias of SST from the model median from uncorrected CMIP6 model relative to OSIA that show the magnitude and the spatial partner patterns of systematic bias, particularly in the Atlantic Ocean here, the north part of Atlantic Ocean. And then the right panels here, it shows the mean bias of SST model median from the bias-corrected CMIP6 relative to OSIA data that illustrating the reduction of discrepancies following the application of the bias correction techniques. This comparison highlights the effectiveness of bias correction with notable improvements in SST representation, especially in the northern Atlantic Ocean, where the raw model biases were more pronounced. And then this histogram presents the mean SST bias of CMIP6 model output relative to OSIA again, historical, and then the analysis is based on the median also for all the 28 CMIP6 model, but for 13 ocean subregion around Canada, what's showing in the map below here. And then we saw here two set of value. In the blue one, we have unadjusted raw model outputs, and the red one, we have the bias adjusted output, allowing for that allows us to a direct comparison of the model performance before and after the bias correction. Across most of subregion, the unadjusted model saw small but consistent positive bias, indicating a general tendency to overestimate SST compared to OSIA data. Once we apply the bias correction, the bias are significantly reduced, which demonstrates that the bias correction method is effectively in improving the alignment of model SST with observation conditions across diverse oceanic regions. And then after that, I done some analysis in the future comparing here the tendencies. We map so the linear tendencies in SST for the historical period, that is from 1970 to 2014, and fetal projection the fetal projection, I take all the period 2020 to 2100 under all the four scenario here. And then you saw that is the historical, just to show the reference. And after that, and that is the first scenario, the second one, and that is the last scenario. You saw here the magnitude of the tendency increase with the emission scenario. Also, the spatial patterns shift with the warming level. Low scenario saw more localized warming, ranging, for example, for the SSP to 4.8 here, we saw the warming is ranging from 0.2 to 0.4 by decade. And then if we saw for the last scenario, that is the SSP 8.5, for this one, we can see that the warming ranging from 0.5 to 0.8 by decade. That is more for this one. Again, and then also if we remark the Arctic amplification is evident in all scenarios, but become dominant in the two last higher emission scenario, that is the SSP 6.0 and the SSP 8.5. Again, here I saw a box plot of the median comparing the historical and the last century period, that is 2070 to 2100, that illustrated the distributions of SST, but is the spatial mean. It is spatial mean across all Canada and across all scenarios. And then the bar, if we saw for the SSP here, 5.85 here, we are the larger one for the history, indicating a greater variability and spread under higher scenario. Here is a clear progression in SST mean value from the low scenario to the higher scenario, reflecting the model ensemble sensibility in increasing radiation forcing. This confirmed that SST projection responds to a level of greenhouse gases emission. And then that will be the last analysis here. Is the histogram illustrated the projected SST change between the historical and the last century period based on the median of a model output also, but we model, but we bias corrected them. Again, it for our 13 subregion ocean across Canada, but here I didn't show for SSPs, but just for 3 SSPs, because the change is a little change for the SSPs 2.6 is the change is a light change here. And across all scenario and subregion, SST is projected to increase with a magnitude of change directly linked to the emission scenario. For example, under the SSP 4.5, the projected warming is more moderated with a minimum increase of approximately plus 1.3 degrees C. In contrast, if we look at the SSP 8.5, representing here the higher emission scenario, it shows the most significant warming with some subregion experiencing increase up to plus 4.8 degree. Here projections highlight a consistent warming trend across all Canada marine regions. The results emphasize the critical role of emission mitigation and limiting ocean warming and its potential impacts on coastal ecosystems and coastal communities. And in conclusion of this presentation, this study analyzed the CMIP6 model SST-based correction data in ocean region around Canada. The results show a light SST bias between the model and the ocean historical data in the Pacific Ocean and the Canadian Arctic region, and it saw a notable bias in the Atlantic Ocean, reaching sometime -5 degrees C. But the bias correction effectively reduces model bias as demonstrated by the improved agreement between the corrected model output and the ocean observation. The next step for this project will be to do some user engagement to know the local community and all industries what need to use this data, and then what we want it to be, and then if we need some indexes derived in the SST, we will calculate that and integrate it in our portal naming climate data. That's thank you.